In my last video, I was making new heads for this boring bar and making some additional new bars. One thing I forgot to mention is be sure to file off the screw poking down through the bottom, or if you're doing very close to the minimum diameter of the bar, it will rub. In this case, it would have. This is the part that I'm actually making these parts for. I've done them before, and all of this is kind of repair work on tooling that has failed. So this is the groove tool that I've made before to do these internal grooves here. So we're going in through a 5/16 diameter hole, 0.3125 diameter hole, and putting a groove in that is radially almost 60 thousandths deep. So a lot of overhang of the tool. So this whole video is going to be on how I do these in multiples to make them practical and also make them interchangeable and repeatable position-wise in the CNC, so that if I break one or whatever, I can literally just smack a new one in and carry on. So in the same way that on the last tool making, I had a system to enable changing the bits per operation rapidly to make it efficient to make. The method of orienting the tool in this case, which is the 45-degree flat, this isn't new to me or to many others. Lots of manufacturers use this method. And how this works is in the tool holder you'll have a pin or a reference edge, whatever, that comes in, and this axially and rotationally orients the tool so that the location of this tool is fixed. And if they're all made the same, you can just interchange these just like an insert tool, even though it's not an insert, and get repeatable location. So that is what this design is. You'll notice here I've made this so that this can't be put in the wrong direction by making the face of this pin be on center line and hit this. The block you're seeing here is what I use in my punch grinder to sit, where I can just change this tool simply by loosening the two set screws. I put this piece in and do whatever operation I'm doing, whatever setup I'm doing on the tool, particular cutting angle or whatever that I'm grinding, and I can just quickly change these in and bump, do that operation. So the setup gets spread out for all the parts. And also, since this is the repeatable location, all these cutting edges end up in exactly the same place relative to the mount, so that they repeat for CNC wise. I don't have to change any offsets on the CNC when I put this in and interchange it. But this block has been designed to sit in the punch grinder, and I'll show that later on. Now, in the lathe, I need something to be able to do the same thing. So this is my gang tooling that I've designed and built. This bushing is eccentric, has a hex on the back so that you can adjust center height by rotating the bushing. But this has a special bushing where the bushing is split, and in the back half here I'm holding a piece like this that interfaces like this with the part, so it's doing the end control. So this allows me to position this, rotary position it, get this tweaked into where I want the tool level and axial position, and then this doesn't get loosened, this stays put the whole time. But I loosen these, which are actually clamping the tool each time. One of the important things that has to be taken care of is that this has to be free, so that when you seat, there's no drag on here. If this is too draggy, you won't be able to push this back firm enough to make sure that it actually seated. So this is actually a screw that is expands the slot. I have a set screw on this side. This is tapped just like the rest of them. And the reason I'm using this hex head screw here, these are all actually grade 8 screws, is that the tooling is going to stack right next to each other, so I need to be able to get to this one in between when these are stacked. These two particular tools are right next to each other, so I need to be able to get to this to loosen this. Once I've got this in and seated, then I'll back this off so that now I can clamp with these and hold the tool rigidly. And the tool is held like this. It's working upside down. So that's the whole system as far as how this repeats. And you can see here, I can't. This is sprung shut, and I can't get this loose now. So I actually have to tighten this to get this to free up. Now I'm free to be able to put these in and out. So this is real simple, makes life real easy on the CNC. And like I said, this isn't. There are lots of people who, lots of companies who make tooling like this that is replaceable with the exact same system. Some are a little different. Some have a set screw with a whistle notch that pushes it back, whatever. But the principle is the same of having a angled flat that seats with a mating part.
So here is our boring bar. We have our 45 degree on the end here. We have our sort of semi-elliptical relief, which I'll show you here in a moment. And we have our carbide end brazed on here. Here I've turned off the actual carbide piece, so we're looking at the cross section of the actual extended bar here. And this is a 5/16 diameter hole, which happens to be the same as the boring bar shank, main shank. And you'll see here by doing these two radii offset, we're getting the most distance vertically here. This from here to here, we're keeping this beam as vertically as high as possible, which is going to give it more bending strength in that direction. These radii are actually smaller than the half of the 5/16 or 5/32. They're a little bit smaller, but they could actually have been the full 5/16, and it would have actually made this a little bit higher. But I did this to get a little more clearance. Here is a master sketch that I did as the very beginning of the part. I did my 5/16 diameter outside. I did my 135 radius on both cases here with the offset of the arc centers in order to get this 90 thousandths of clearance from the cutting lip, which is at 300, which leaves me 12.5 thousandths clearance to get in the hole with the boring bar to start with. So it's tight quarters, but this 90 is giving me 30 thousandths of clearance in the back of the bar here to be able to sharpen these as a group. It turns out most of the time you get a chip tangle or something and rip the heads off of these, and that's one reason why they're made with a brazed on head, is so that the bar is still good and easy to replace. So this is all the layout that I did here for the locations, and these values, these offsets from the center of the actual bar, are what I use on the punch grinder to offset to grind these radii. Zoomed in here on the carbide piece, and we have 3 degrees of side clearance on both sides of this in this orientation, and then we have 3 degrees back clearance the same way on both those faces. Now the thing that gets tricky is if you had that insert or the carbide piece brazed on square onto this tool holder, you would have to grind this, and you would have to hand grind this as it wraps around, because remember, this comes very close to the bore all the way, so you can't have a sloppy type of a runoff here of this clearance. If this was doing a huge diameter where this ran off this way, you could do your normal clearance and just a little cleanup here and you'd be good. This has to be good all the way around. So an easy way to do that is to actually grind this 3 degrees both directions, 3 degrees in the one way right here and 3 degrees this way. And I'm going to turn the this piece off. I'm just going to hide this, and you can see that the end of my bar is ground compound angle 3 degrees both directions. It also allows me to finish, just lap the face of the insert except where it solders on, and get a get both my angles done, and without the having to do anything fancy. This is already ground, already has everything clean. So when I saw these pieces off, I literally just silver solder them on, and I'm ready to go. All I have to do is grind all the other surfaces relative to that. So here is this top flat right here where we're getting some clearance, and this angle right here facing this direction is still giving me all of my silver solder bearing area, but it's giving room for these chips to kind of get forced into the hole. Fortunately these are through holes, so I don't have to worry about chip packing. So I'm kind of directing the chips back that way and keeping the strength of the tool, and so that's why that is done in that manner. Now I'm showing you the actual cutting edge details that I've got here. These are the clearances. You notice by putting this 5/16 diameter circle offset to touch the lip of the cutting tool, I can check for clearance down here where this is has to clear that, so I can come up with the angles that give me that clearance that I need. I'm also putting in a we'll clear this up a little bit here so you can see what's going on. I've got a 10-degree back rake on here done with a circular tool that's 0.94 diameter, which is a diamond tool. And I also have the arc center locations of where this is so that I know where to go to when I go into Bridgeport and put these in. I can actually put this curved chip breaker in there using a rotary tool. So you'll see that in action. But I'm using this sketch layout to determine where those things are. I know I'm 135.5 off of center when I indicate in on these parts vertically, so I can move off there and then just come in and touch until I clean up the edge, and I know I've got my correct radius in there for the chip breaker.
Here's my repeatable location block for these tools mounted in the punch grinder. Just a few points about V-blocks in punch grinders and V-blocks in general. You'll notice that this wall thickness right here is very thin, so if I just ran that screw down on this, several things would happen. Number one, I could actually collapse the wall here if I tightened it too tight, and this wouldn't fit in anymore. Also, this would have a tendency to spring up on each end and press down in the middle, just because of the nature of everything acting like rubber. Press down here, this is going to do this, and that's also going to influence the axis of the part out here. So a spreader block like that is always a good idea, no matter what you're clamping. But also the axial location this way of where this screw bears relative to what's bearing in the V-block has a huge effect on whether this points downhill or uphill relative to the axis of rotation of the punch grinder. So that is where you carefully position this and look for the midway point of the bearing area and snug it with the spreader. And then you can fine tweak if you have to tweak your axis just a little bit. If you're doing very, very precise work, you can get this to where what it's grabbing is not influenced by improper techniques with the V-block. Some general concepts here about how I use the surface grinder as a grinder. You think of this is an axis of positioning. And by using a angled block as your reference here, you can slide up against your reference rail and instantly get a known angle either direction. In the same way, this can pivot in the vise like this. So you see me using multiple vices and things like that. It's because it's a very quick way, and with the angle blocks, it's a very fast way to set a position quickly and be able to just dance around here almost quicker than fooling around with a tool and cutter grinder. Nothing wrong with them. And if I had space, I'd probably have one. But the surface grinder can do just about 99% of the things you do in there. It can be done here. Maybe not as conveniently, but it can be done. Since I'm not making these bars from scratch, I already have the boring bar bodies done, and I'm just replacing the heads. I'm just going to go through the motions, showing you the orientations and what I went through. I'm going to do it with the part facing this way, so it's easy to see what's going on. But in reality, to grind, this would be pointing that way, and everything would be happening on the back side. So first thing, I'm going to insert my part, make sure I'm seated, put some axial pressure on it, snug the set screws. We're not entering into a contest of strength here with the set screws. We're just snugging them enough that we know that the part's going to hold still. On this punch grinder, I have intentionally ground a flat surface here that's true to the axis of the punch grinder, where I'm going to sit my indicator. So first step is indicating in the round shank, because that's my reference for all of my offsets. So I adjust my V-block up and down until I've got 0, 0. And in this case, we're not talking about tenths here. This is just relief cuts, so we don't have to get carried away. You see that flat is to mount my indicator setup that I've made for this. And it grips with this flexure right here. I have two O-rings in between here that control this, such that this actually, as this pulls up, it expands, grips the sidewalls this gives it something to resist it just scooting up the walls. Then once it grabs, then it starts to compress this one, and it holds this rigidly to the machine, and it repeats very precisely to be able to put this on and off. So now I have 0, knowing that my part is now centered. Now I can just offset this by the amounts that are on my drawing. So I have my drawing oriented as the part is sitting in the punch grinder, so I don't get confused. I look for the actual arc that I'm trying to grind, this one. I come over here and say it's 0.0213 offset, and which way do I have to go to get this? This is the current arc center where the axis of rotation of the grinder is lined up with this origin mark, the center of the OD. I have to move down. So now I just loosen my V-block gently, just enough that it's free. I need to move down. This is the pinion that moves this down. So I'm going to come over here and go to my 0.213. The tenths really doesn't matter for what we're doing here, but close enough. 50 millionths off. And like I said, this is totally irrelevant. This is just a clearance. So now I put my indicator on here just to show you that roughly that is running, that's where it was ground. And that's exactly what we would have done. We would come down here with a grinding wheel, touched, and just cleaned up on the back side, and we would have known where we were to do that. Now, once we've done that side, we would change each one of these parts in and out. We'd loosen the set screws, take this one out, put the next one in, same operation. That's the beauty of the quick change, is that this setup, which takes a fair amount of finessing, gets distributed over multiple parts. So now we're going to look at the other side, and we look at this radius, this one, which is actually the major material removal on here. And we look at the arc center of it relative to this axis, and we see that we're 81.0813 inches. So now we're going to move, and that's the other way to get to here. From that, it's just further this direction. So we're just going to move further, because here's where we were. To get to there, we're dropping still. So now we're going to go to 0.813. So I'm loosening my screw down here again, just enough to be able to travel. We want to scoot down to the 0.813. Loosen a little bit more until it moves a little easier. There we go. Come down here, 79. Now you can see that this gauge is like, this is like insanely handy, being able to make these moves, and you realize that that's close enough. I'm not worried about the 3/10. I'm trying to show the principles here. We're not fooling around with every last detail. Now you'll see the beauty of being able to just remove this and not lose our location. Take this off. Now we can come down here and focus on what's going on, and we're going to actually be flipping over, because this is the side we need to grind on. I already have my indicator zeroed here on this, so that you can see that even coming back to this old location, this is running true. That surface, I'm sitting on that, on the surface right here where we ground, and that's good. Plenty close enough. Remember, I said this would be facing the other way. We'd be working on the back side of the punch grinder. But we know we would touch here, because we know that we're taking, from the drawing, that we're taking exactly 100 thousandths radially from here to here. So here we can just come on here, 0 on that top, and then just plunge down, taking 100 thousandths off, move over with the wheel, plunge down. Okay, come back and just do a traverse pass, and we're good. Take this part out, stick each one in, do that every operation to all 6 of them, and we're good to go. And we've done the radii. Since this chamfer, 45-degree chamfer here, is concentric to this position we're in right now, we're going to do it right now just simply by pivoting the whole vise, or the whole punch grinder in the vise at 45 degrees, coming down in here with the wheel, and just plunging down till we meet the corner, and we're good to go. Same situation here. Everyone, interchange every part, zip, 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 do it to all the 6 parts. Now this will be the first actual operation that is the real deal for redoing these heads. So I need to clean off this surface, hopefully just touching back to where it was originally. What I'm doing there is I'm doing my angle this way, my 3 degrees in this direction for my side clearance, this being the front of the tool, so it's falling away this direction. And then to get clearance this way, I'll be tilting the part so I get a flat like this. So it's 3 degrees this way, 3 degrees this way. That forms the compound 3 degrees both directions on the back side of the tool when I solder the flat carbide onto it. So we're going to flip this around and do the real deal on the correct orientation. So I need 3 degrees downhill. So I'm sitting on my 3 degree angle block, and then I'm just gently grabbing the vise. And you notice this is why I'm not grabbing in further, is because this is my mount for my motor drive. So, but we got plenty good enough grip here. And there's my 3 degree block. Now I can use my 3 degree block down here on the table to set the angle in the other direction. Here I'm using a solid 1, 2, 3 block. Very handy on a grinder because it's super easy to clean, to space out my 3 degree block, which is giving me that angle so that I've got my compound angle set properly just by using the vise and the angle blocks. Here I'm just tickling the surface. To change the part, I have to release my lock, get up where I can get into my set screws here, pull out a piece, stick the next one in, press axially while I load it while I snug the screw, snug the other one, make sure I go back to my other location, make sure I'm actually on the 90 degree mark, which is easy to forget, and then I'll run through the grind. Take the part out, lather, rinse, repeat with all the pieces. I do a lot of cutting off with these very thin diamond and or CBN discs, but this extra thickness back there on the nut and that spacer keep you from cutting off things as close as you'd like to the collet. So I'm going to modify that. This is my collet mounted backstop. This is the actual arbor off the grinder, and I've indicated it in. So from the other piece turns into what you see in the lower piece there. Plunge a bevel on the nut with my adjustable tool. Part off 2 spacer rings. Spacer, original spacer, wheel, and our modified nut. Now you can see I can get really close to the collet nose and cut things off much better. Now we're going to use the D-bit grinder to slice off some pieces of this 5/16 diameter ultra micrograin carbide. One real important thing is to have the angle here set at 0 so we get a square cut, and be at 90 degrees here on the stop, and then we just have to feed in. I'm going to touch off with this. I have my dials zeroed on my main slide, and I'm going to come in and bring this into here. I'm going to come in and touch with the wheel using the feed of the actual spindle feed on this. So I'm going to turn on here, loosen my spindle lock, come in and just touch where I can tell that I'm touching on here. There we go. Lock my spindle. While I'm here, I'm going to get rid of the little tit on the end there. So I've cranked over my 135 thousandths, which is going to slice me off a disc enough that I'm not going to run into trouble. I'm going to turn the vacuum on, so you're not going to be able to hear, but I'm going to cut this off in real time. does. So that disc is cutting off really close to being 1 millimeter. So I only need 5/1000ths on there for cleanup. So I'm going to back off to 130, which will take us down to 0.90, leaving us 5/1000ths to grind off the end. There's our 4 little pieces of carbide ready to go, be soldered on. Just think about how easy that was to cut those off. Easier practically than high-speed steel. When you have diamond super abrasive tooling or CBN tooling, things just go immensely better. Don't be afraid of super abrasives. We'll take the one side and give it a rub on the diamond disc, diamond plate. I want to get a nice uniform mechanical tooth on there, make sure that this is flat for where we're going to solder, and it's also forming the one cutting face of the insert. So that's what we're doing on these. So I deburred the edges of these with a diamond file, and then we've glass beaded them to get a nice uniform matte bright finish that's good for the silver solder to get a bite. We have our piece gripped in the vise. We're all set up for the supporting the part, clamping the part, not clamping it, but holding it with a three-legged holder. We have our face here that we just got done lapping with the disc with the diamond plate. We're going to stick this down on here. Remember, this surface that we're putting that down on is actually pressing that on 2 separate, well, compound angles actually. And I'll back up here so you can see what I'm doing clamp wise. You can see there I've got a pretty big chunk on there, so I've got good support. But now I'm going to come in and focus in here and make sure I'm fluxed good. But the important part here is that we're flush on the back, because if we're not going to poke out enough on the bar. So that's the main thing. Everything else will come out in the wash as long as this is good. Right there. So I use that back of my scale there to push that up. Now I'm going to flux this right here, because this is where I want the silver solder to be able to wet in from this side. This is where I'm going to touch it. Actually, my paste is a little bit dry, but I'll live with it. Needs a little bit of water, but this will work. So if I come in here and warm this up gently. Blow the flux off. We'll wipe slowly with a torch, and I think we got a good joint there. Hot water dissolves silver solder flux very nicely, so that means that a heated ultrasonic is really nice for removing it. So now that these are soldered on, you can see the 3 degrees of side clearance on this right hand face, and then you'll see the 3 degrees in this direction also on that face, and that's all from just grinding that angle on the surface that we silver soldered to. So that's a pretty handy trick for getting that clearance all the way around. I've taken a needle file and square needle file and gone in here and took away the majority of the fillet in this area, because this still has to clear. It has to clear all the way around. That was the whole point of doing this by tilting the carbide piece, was to get clearance full, all the way tangent, all the way around this. So getting the worst of it off is good, because then the glass bead will remove the rest of it. Glass bead erodes much faster than steel, significantly. So you can literally clean the silver solder off where you want to just by blasting it, which is what I'm going to do right now. Here you can see we've got rid of that big fillet, and we have plenty of clearance there. There's about 30 thousandths from the bar surface to where we touch the bore when it's at full groove depth, so that won't be an issue. Plus we have the 3 degrees back clearance both ways that's going to be getting away from there. We're going to grind this carbide on the back to match this back curvature right here, which is the 0.0213 offset that we showed earlier in the beginning, the very first one. And we only have to go around to 180 degrees each way, but we have to get that to be less than or equal to this back of the bar. So I'm going to set that right now. So I'm loosening my V-block clamp, trying to find my hole over here for my thing. Going to go up to, look at that. Wow, close enough, 0214. Snugged up. We also have removed the 3 degree block from here and under here, so we are now sitting square to the grinder in both directions because we're doing a cylindrical surface. Now we're going to install our piece, find our slot, axial pressure, snug the set screws. We're going to put a diamond wheel on, and we're going to grind these. Since I'm grinding a cylindrical surface and I need to take these in and out, I'm going to set a table stop, so when I come in here, the grinding wheel center line is right over the punch grinder center line. So I've taken half the width of this, which is 2.0375, and I hold my scale against the side of the head here, and I just move until I'm visually saying, okay, I'm darn close. If anything, you want to err with the punch grinder being a little bit this side of center, so that if you're sitting on the part and you go that direction, you won't cut more. You will be coming off the part, not climbing into it a little bit. So I'm putting the stops on. I'm going 105 degrees either side of the flat here. So I'm not going to run into where the cutting edge is going to be, but I'm going to round off the carbide as far as I need to go to be tangent with the back of the bar.
So if my stop's set, I know where my zero is, where I'm going to be touching tangent here on the back. Then now I'm just going to oscillate back and forth, just taking a little bit at a time and creeping around. Okay, I'm at my zero. Now I'm just going to use the width of the wheel. I'm going to move around a little bit on the wheel to exercise all of it. Not critical, I'm just trying to keep the wheel from wearing a severe groove. So here you can see the contour. You can see where I've touched tangent to the steel, actually ground the steel there a little bit, and that makes sure that that carbide on the back is going to clear in the bore. So now we'll just change each one out, doing this exact procedure to all of them.
Now we've done the back relief to make it match
match the back curvature of the bar on all four. Now I'm going to bring the part back on center. Not that it needs to be, but just so I know that I'm not going to get bamboozled, because I'm going to do all the other angular cuts on this while we're still in this basically cylindrical grind mode where the axis is square both directions. We're going to move the shaft back concentric, but notice the repeat of this going back on in the same location, 0.0214, exactly where I set it from the last operation. So we're going to loosen our bolt that holds our V-block snug, find our drive here and drive up to 0, in the ballpark of 0. Okay, 0. And now that this is running true, the main shaft's running true, and we don't really need to be offset for any of the other operations, but this won't give us any problems of being off center, not anticipating that. Here I have my punch grinder set at 7 degrees. Here's the orientation of that tool with that 7-degree settings, which means that the tool is rolled this way 7 degrees, which is giving us our back clearance on this cutting edge. Here's our location with that stop set where the 7-degree setting that we saw in the back. But because the access screws here for tightening this are back here, that's why I had to set a stop and couldn't just lock it. If those screws were accessible directly without moving it, I could have just locked it at the 7 degrees and left it. But each time we're going to have to spin this around, take the part out, spin it back, and tighten the lock. I removed the original lock system that was on this punch grinder in redoing the bearing system that's in it. So this crank arm I have converted to be the lock. I have the pin sticking out here enough to grab, and it grabs here. You can see this is free to turn now, but when I tighten this, even just finger tight like that, it grabs the pin and this simultaneously, so there's no play and virtually no influence on pushing the spindle axis around. So just a pretty easy way to get that thing to lock. And just so we're clear here, I'm grinding this little facet right here, which is 83 from 90, leaves 7. That's a 7-degree cutting angle. I'm touching up the 2 bars that were barely used, and I'm just kissing the 7-degree angle there. And this is where we'll take all the other ones too. One thing I forgot to mention here is that I'm grinding with the cutting direction of the grinding wheel going into the cutting edge. So it is pushing into the cutting edge as it cuts, not pulling off. Carbide being a brittle fracture mechanics type of cutting means that going the other direction would increase the amount of edge break out that would occur on the cutting edge. Here I'm going to be grinding the ones with the new heads soldered on, the 4 pieces with new heads. I'm going to be grinding them down to the same value. That's it. Lather, rinse, repeat. Next, I'm going to do this 20 degree, 90 minus 70, 20 degree clearance. But I'm going to shrink this up a little bit to only about 5 thousandths to help this be able to cut through. Wrap chips are a problem. If you get in here and you get a chip wrapped over this and it goes to try to bite through, it creates huge pressures because it's masking the cutting edge. So having this be very small to help penetrate through that is a help. Moved our setting to 20 degrees and repositioned our stop. Here we've ground that 20 degree clearance on there, leaving that little band you can just barely see on there. Having an existing tool to touch off on makes things go a lot quicker. This isn't a critical thing. This is the 30 degree facet, which is 60 degrees. And on this case, I can use the
There we go. Just knocked the blue off. In this case, I can just use the straight 15-degree indexing of the punch grinder to go to my 60-degree. Here I don't need the stop because I can use the straight every 15-degree indexing. But this grinder uses the 0 to 90 in 4-quadrant type of divisions, which isn't bad, but there's 4 different 60 locations on here, so it's really good to mark where you want to get back to when you're moving this thing to get to the screws that hold the part back and forth every part. Make sure you mark it.
Now I'm grinding the flat on the new ones that have the new heads. Plunging and then traversing. Lather, rinse, repeat.
Now we need to cut this 45-degree gash through there, giving us the top of the tool. And we have the whole vise set up just like it was. All I did was release the chuck, clean it off, put my 45-degree plastic triangle in here because the angle's not critical. And we're going to go ahead and get lined up to grind that. I know I could get a lot of flack for this, but in my opinion, the best way to tighten the spindle nut on the surface grinder is with an impact wrench. Obviously, you want to use judgment in how tight you do it, but keep in mind the impact wrench puts pure torsional impact on this. No side loads to the bearings. It's all inertial, and the rotor of the motor of the spindle is what keeps everything from moving. So anything you do with a wrench, leaning on it, whatever, tapping on a wrench, puts impact loads on the bearing. This does not. Another tip is, if possible, always buy the biggest wheel that'll fit on the grinder. I always try to buy 8 inchers, so that gives you another radial inch of clearance to clear things when you're working in this zone. So this happens to be 6-inch, and I'll get by on this, but I always try to buy 8-inch wheels, super abrasive wheels, to fit on the grinder to give more space when you get into these tight situations. Lining the wheel up on the existing cutter. Existing cutter is really handy for coming back and get your setups real close. And you can see here that clearance-wise, you can see why I'm talking about 8-inch wheels being a better choice, but I'm going to make it here. But only because that wheel was spaced out, like I mentioned in tool room tips number 2. I have my stop set here just so I can come back without looking on the back to release my parts to change them. I'm taking out the bar, my previous bar that already had the geometry on it from the last time I did these. Now I'm sticking in the new bar. You can see why this is very important to not have 2 ways to get this part in there, and that is accomplished by having this flat large enough that it won't go behind the pin and just skates on it. If this was out sharper, it would allow you to get into 2 positions, radically different positions, but 2 180-degree positions with a different axial location. And that could cause serious trouble. So that's why I grind just the 45 on here, that this flat is big enough that it can't get in the wrong position. There's only one place where this will go in and seat. I'm leaving my saddle zeroed and not moving that at all. I'm strictly going to plunge down, and I will probably traverse off. No, actually I won't. I'm just going to plunge down, period, because this isn't actually forming the top cutting angle. The radius tool will be. So we're just going to leave this sit the whole time and just plunge down.
While I'm plunging down through this, I thought I'd do a little commentary on the whole thought of making these tools instead of buying them. Nothing wrong with buying tools, but doing things like this is a means of developing skills that can be used other places. If all you do is buy tools all the time and don't learn some of these tool making skills, There's going to be times when you're a lot of things you didn't learn along the way that you learn by making tools. And obviously, production people, they can't be fooling around doing this. But as a hobbyist or as a one-man shop, doing projects like this, making tools, learning to make them efficiently, and probably not necessarily any more expensive if you do multiples like this. It's just a good means of spending your time and making projects to do things that you wouldn't normally get a chance to do. So some of that is the point of these things. Pick something that you need to develop skills in and have at it and learn along the way until you are happy with what you got.
Put my plunger in the back, rotate up so I can get to my screws, set screws, release this.
Here I'm at the same setting that I was for the gash. I'm 30 degrees rotated. I'm going to creep feed through full cut, and then once I'm there I will traverse back and forth as I rotate back to the gash setting. Now I'm going to rotate back to the stop. That's it.
Here's that gash. And then where I went through 30 degrees off from it and then rolled down into it. That's just to give room for chips to be able to evacuate out this direction. I have this vise, in this vise, upside down just to point out a principle and something to watch out for. You see me grabbing a vise and vise often, but most vices have a gully like this clean through. And what that means is the only thing supporting this that's less compressible is these ends. In between here, this is just these beams doing this. So you can grip and you'll think you have a good grip, but because this can just flex away in the center to some degree compared to out here, and the jaws of the precision vices tend to stay as perpendicular as they can, these won't follow that, and you're going to get a situation where this vise can slip. You have it tightened and it seems tight, but you put a little extra force on it and it scoots. And it's because this is only gripping snug up here where it's solid. So that's what this jack screw is for. You could use an adjustable parallel. You can use any means of getting some support in here such that this doesn't just collapse when you're gripping it in the vise. This is just a screw with a nut, and this work against each other. Keep in mind that this is a very small column and is somewhat compressible also. Much more compressible than all this mass out here. So I actually spring this vise open maybe 5/10, measuring with calipers, to kind of pre-stress it such that when this collapses a little bit, it grabs parallel and is good and tight. So just an important thing to keep in mind when you're doing vise in vise. Here have the inner vise sitting flat just temporarily in order to set the 3 degrees lean of this block. And if we zoom in here, you'll see I have this block in, and what I'm doing is this long 1, 2, 3 block is so that I have access here. This vise is going to get raised up when I do the other angle. I have a 3-degree lean, which is leaning this way to put the back clearance on the top of this tool here. So I just have a parallel in here with the ends are ground square, and I'm sitting tight to the bottom and against this wall, pushing the block against the 3-degree block and then snugging up the vise. Now, I'm going to spin this vise 180 because if I ground with this, I'd be grinding off the lip, which I just got done telling you is not good on carbide if you have any choice. So I'm going to put this vise in 180 when I go to do the other angle. So you can see I have a 3/8 parallel for the 3-degree block to sit on, so that I raise the vise up so that when I grip this with the 3 degrees here, I'm sitting up above where I can get to it with my wrench. When I'm pumping this vise here, what I'm feeling for is I'm putting pressure on this vise to physically seat it on this back face. If I just let this droop and don't pay any attention, it can actually catch corner to corner and be almost tight but not. You got to be very careful to make sure that you're actually seated and squared up. You see how much I raised up there? That is where I need to be. So you're actually holding it, feeling it tight against the block. I'm feeling it tight against the angle block, and I'm pumping to make sure that I'm not getting any motion. I keep putting pressure on up top here until when I tighten, I don't feel any rock. Then I snug it. That's just good practice. It's very easy when you get an aspect ratio of grip height to grip distance to get a cross corners grip that feels good but isn't. So here we are ready to grind. I have the 1/4 inch wide wheel on. We're grinding the end compound angle, which is 3 degrees lean this way and 3 degrees lean this way to get both side clearance this way and on the back clearance. I've set my wheel just touching here with the existing tool, but since we ground a little teeny bit off of the seating surface, it'll still leave me a little bit to measure my actual tool thickness. So we will release this, put our wrenches in here in the back, and we'll put in another piece like this. Press down firmly, tighten our 2 set screws, and we're good to go.
I've already roughed some off. I've got about 12 thousandths to go. Points down. I need about 2 thousandths to work with. Move over. Got 2 thousandths. Now I'm going to reverse grind on this. And I'll measure and see where we are. So it's measuring about 0.87 and a couple tenths. So I'll take 2 thousandths and a couple tenths off of there and we're good. Okay, we're measuring right here and we're at 0.85 right there. So we're done. Just lather, rinse, repeat for the rest of them.
One thing I need to mention here is that when you're roughing off a lot of carbide here dry, it generates a significant amount of heat, and you need to be aware that this steel shank is growing from that heat. So you need to rough it, blow it off, let it cool off, or use coolant. But make sure this is back to room temperature before you start dusting to get your exact width, because otherwise this is going to be a lot different than you thought, because it grows up into the wheel, and then you go to your final size and you find that after it cooled off, it's already below where you want it to be. So got to watch that heat. Now we're getting ready for the final operation of putting that radius chip raker back rake style of groove in the tool. I have my holding block. I have the 1, 2, 3 block in here to be able to get access with the Allen wrench. I have my 1, 2, 3 block is what I use to square that vertically in the vise. Raised it up so that this would be, I'd be able to indicate on the cylindrical diameter here, which is what we need as our reference from the SolidWorks modeling I showed in the beginning, where I know relative to this axis of the shaft where the center line needs to be in this direction to line up with the cutting edge. So we're going to indicate in now on the shaft. So I have an indicole mounted on here, and I've lined this up so that we're 0, 0 down here on the actual shank, which is our reference. I have a piece of 440C hardened shafting in here to use as a lap on the carbide, and I've got it tapped in, pushed in until it runs true out here so it doesn't beat the part. I have some Sharpie on the lap, and I'm just going to come in here and come until I just nudge the Sharpie so I can tell that where I'm touching instead of dial, so I have some reference of when I'm actually, there we go, right there. So I'll set my 0 there and I'll know where I'm going to start touching. Using some 6 micron slurry here that I'll be brushing on. That quick, cut that recess in there, just meeting up with the existing cutting edge, and virtually no edge chipping, and nice smooth finish there for the chips to run through. Now I've cleaned the lap off, just wiped it clean from the 6 micron, and I have 1 micron on here that I'm using on the same lap. That black you see is carbide. Now I've cleaned all the free abrasives off, and I'm just going to let what is charged in the pin start to work. And as that starts to form a sludge, the finish gets better and better and better. Let's see what we've got there. As you can see there, this mirror, using just what's left and letting it run dry is how you get an even finer finish than what the grit gives you when there's free abrasives around. So now do that to all of them, just with a dry lap. I'm over on my lap. I'm not running the lap by hand, by power. I'm running it by hand, and I'm on the lap, and I'm looking for where the debris shows up on the lip to adjust my angle to make sure I'm hitting the original face. So I'm doing minor little tweaks there, and I'm just spinning this by hand because I don't want to take hardly anything off. All I want to do is improve the finish. Last thing is just putting a little break edge on the corner to give it a little strength. There and there. That will help that corner keep from breaking down as quickly as it would if it was left sharp. Here's the finished product. This was just done by hand to make sure that the coolant flow this way wasn't obstructed. Get any lips that were hanging here without reducing the actual bond area of the silver solder. You can see our lapped cylindrical chip breaker there. And then we'll get the glint on the, right there is our cutting lip that we lapped also. There's the chamfer. You see the glint there on the chamfer on the 4E5 on the corner break. Same thing on this side. So that's it.
Here's the gang tool setup that these bars go in, and there is the groove tool and the boring bar.